Our field trip begins at the University of Alberta. Here, engineers learn how to design structures such as buildings and bridges. They must keep in mind the balance between those things which keep buildings standing and those which try to bring them down. Force is the push or pull that acts to change the position or shape of an object. Think about holding a ball in your hand. When you squish the rubber ball, your hand is applying a force that causes the ball to squish. If you push a ball along a tabletop, your hand is applying the force that makes it move. An external force is applied by something else. For example, the wind blowing in my face is exerting an external force on my body. Your hand was exerting an external force on the ball when you squished it. Gravity is another external force that is always pulling on an object. It is also important to know that mass is the amount of matter in an object. A greater mass means there is more matter that gravity can pull on. Usually, people refer to this as weight. If you picked up a small piece of metal with very little mass, it would not be that difficult. If you tried to pick up a big piece of metal, there is a bigger gravitational force pulling on the mass. This makes it very difficult to lift. The mass of a building is very important when looking at its structural stability. Engineers need to know if the structure can actually hold up all of its own weight. During the design process, engineers must consider the load a structure has to resist. Load is an external force acting on an object. Your weight is acting as an external force on the chair you are sitting on to take this field trip. Your weight is a load on the chair. There are two types of load to consider. The first one is static load. Static load is a force that does not change. The force of gravity on the mass of a structure is an example of a static load. The chair you are sitting on always has the same mass, so its weight is a static load. However, when you sit on a chair, you are creating a dynamic load. This is a load that changes. If you get up and one of your parents sits down, the load has changed. So that is a dynamic load. Engineers have to design structures to resist both dynamic and static loads. Along with external forces, there are also internal forces that have to be understood. An internal force is something that acts within the structure itself. So there are three kinds of internal forces. There's compression. This is a force that squeezes an object together. As you sit on a chair, there is compression pressing the parts of the chair together. If you think back to the particle model of matter, you can imagine all the particles within the object are actually getting a little closer together. Tension is a force that acts to stretch or pull the structure apart. If you are pulling on one end of the chair while your brother pulls on the other end of the chair, the middle of the chair will be under tension. The spaces between particles may get a little further apart. Shear is the third kind of internal force. This is a force that acts in opposite directions. If your brother was pulling on one side of the chair while you were pushing on the other, there will be shear between the two sides. Think of putting your hands together, your palms together, and pushing one in one direction and pulling the other one towards you. That is a shearing type motion. Parts of a structure must resist compression, tension, or shear, or they will fail. If you think about a structure, if it's under a big heavy load and it can't resist compression, it will crumple. We will be taking a field trip around the world to see how different man-made structures remain stable under heavy loads.